In this section, we continue our discussion of macronutrients with a review of the lipids. Lipids are necessary and definitely valuable in the human body. Not only do they have valuable functions in the body, which can support health, but they can also harm health. Many of us understand or have at least heard of the connection between certain types of fats and heart disease. We'll be continuing to discuss this concept in this section, as well as later in the semester when we look at heart disease and the diet connection. Lipids are divided into three basic classes. We have our triglycerides, our phospholipids, and our sterols. Fat is not only useful in the body, but also useful in foods. People tend to naturally like high-fat foods. Take this meal, for example. The lipids in the foods help to create the palatability of the food as well as the visual appeal. Lipids or fats create aromas, enhance flavor, impart tenderness, especially in meat products, help to contribute to satiety. The term satiety refers to the feeling of fullness. So fat definitely helps us to feel full. Fat also contributes to texture. Take, for example, these French fries. If the fries were potatoes that were boiled in water instead of deep fat fried, certainly the color and the texture would be different. They would be white and mushy, as in the case of making mashed potatoes. But the fat that the oil that the French fries are fried in contributes to that golden brown color as well as the texture, the crispiness. We consume fats which are sort of hidden in foods such as cheese, ice cream, whole milk, cookies, and such, and also more visible sources such as oil, butter, and other cooking fats. So looking at the structure of triglyceride, when we think of the term fat, either in foods or in the human body, most of the time we're referring to triglyceride. The triglyceride consists of the backbone of glycerol, which is 3 carbons long, it's a short chain of carbons, and then 3 fatty acids. And if you look at this composition, you'll remember that our carbohydrates, or hopefully you'll remember that our carbohydrates are composed of carbon, hydrogen, and oxygen. Lipids are also composed, especially triglycerides, composed of these 3 elements as well. So a fatty acid is a long chain of carbon units with a carbon with 3 hydrogens on it called a methyl group at one end and an acid group on the other end. Fatty acids can be fully saturated, so some of us have heard of the term saturated fatty acid. All that is referring to the number of double bonds that occur along this carbon chain. With a saturated fat, there are no double bonds. There's only single bonds between the carbons. So it is fully saturated with hydrogens. Saturated fats are commonly found in animal foods. They are also, generally speaking, solid at room temperature. For example, the fat on a steak is solid at room temperature and only softens slightly when left out rather than melting completely. Coconut oil is one of the exceptions to the rule in the sense of it is a plant food which is very high in saturated fat. One of the saturated fats, however, that's found in coconut oil, called lauric acid, does not seem to increase our bad cholesterol like other saturated fats might. And in fact, it tends to raise our healthy cholesterol. Although coconut oil is high in saturated fat, it does not seem to contribute to the risk of heart disease. Unsaturated fatty acids have at least 1 double bond along the carbon chain. These unsaturated fats are usually liquid at room temperature and are generally found in plant foods such as vegetable oils, avocado, nuts, and seeds. Our saturated fats can also be divided into single and double bond. For example, monounsaturated fat contains only 1 double bond, and this is an example of oleic acid. Polyunsaturated lipids contain more than 1 double bond, and those types of lipids would be found in, again, nuts and seeds, vegetable oils, and such. Phospholipids. Phospholipids are similar to triglycerides in that they contain a glycerol backbone, the three-carbon backbone, but instead of having three fatty acids along the carbon backbone, there are two, and then there's a phosphate group. This phosphate group creates a water-soluble portion of this lipid. Think about when you mix oil and water. If you put those two in a jar, shake it up, what will happen? Well, the oil will rise, the water will fall, and they will not remain connected or turn into a solution. A phospholipid, though, has a hydrophobic or a fat-loving portion and a hydrophilic or water-loving portion to it. And it can help to mix lipids and aqueous components like water. Lecithin is a common phospholipid that is made by the liver, and it is essential to cell structure in the body. If we look at the lipid bilayer of a cell, this is basically the membrane of a cell, we see our phospholipids making up the lipid bilayer. The portion sort of facing each other are the fatty acid chain tails, and then our phosphorus-containing portion faces the inside of the cell and the outside of the cell, which are both water-based. One more thing about phospholipids, they are called emulsifiers. The term emulsifier means that it, again, can mix aqueous solution or aqueous components with lipid. The last class of lipids are called the sterols. Most of us have heard of cholesterol. That is an animal sterol. Plants do contain sterols. These are called phytosterols. But in animals, cholesterol is made by the liver. It's not essential. We do not need to consume cholesterol. It is produced by the liver and utilized for several functions in the body. For example, it is part of the cell membrane. It is involved in creating the myelin sheath, which is the lipid coating of our nerve fibers, which protect our nerve fibers. It's involved in producing vitamin D in the body, bile acids, which help with lipid digestion, and also sex hormones. Again, we do not need to consume cholesterol. It is only found in animal foods. So if one is a complete vegetarian or vegan, they would not be consuming cholesterol. However, because our liver makes it, they are not going to necessarily be deficient in cholesterol. Digestion and absorption of lipids occurs both in, mainly in the small intestine and to very little extent in the stomach. In the small intestine, we see bile. As soon as fat is sensed in the small intestine, we see bile being secreted by the really sent into the small intestine by the gallbladder, but being secreted and produced by the liver. Bile helps to break fat globules into smaller fragments. See, we have this larger lipid. The bile salts attack the lipid and break it into smaller globules so that the enzymes can break down our lipids. Primarily, the job of the enzyme is to break the triglyceride into smaller fragments so that they can be absorbed into the bloodstream. The larger fragments, however, will be absorbed into the lymphatic system, which we'll see in just a moment. Here's another example of what biles can do in the digestive process. So our fats are not mixing with the watery digestive juices, but the bile emulsifier comes in, attaches to the fat and the water, creating smaller globules that the enzymes can use. If we look at the breakdown of foods and their fatty acid and sort of triglyceride makeup, you can see that foods are, generally speaking, a mixture of different types of fatty acids. For example, take butter. A large proportion of the fatty acids in butter are saturated. Some are monounsaturated, and others, a very small portion, polyunsaturated. Conversely, if we look at avocado, for example, there's a small portion of saturated fat, large portion of monounsaturated fat, and a smaller portion of omega-6 and 3 polyunsaturated fats. Once the human body breaks down the triglycerides into smaller components, glycerol and smaller fatty acid chains, or shorter chains, are absorbed directly into the bloodstream. The larger lipids, however, cannot mix into the watery environment of the blood, and so they are released into the lymphatic circulation. They are packaged into this lipoprotein called a chylomicron, where we see fat, primarily triglyceride and some cholesterol, packaged into this sphere that carries the triglycerides throughout the body, dropping off triglyceride to the cells for energy. Lipoproteins can be classified by their makeup. Notice the term lipoprotein. So lipo refers to lipid, and protein refers to, obviously, that it has a protein component to it. These spherical lipoproteins carry our lipids throughout the aqueous blood. Again, the chylomicron is mostly triglyceride, and its job is to transport triglyceride to the body's cells for energy. We also have three other lipoproteins, the VLDL, the LDL, and the HDL. The VLDL is primarily going to be composed of triglyceride. This is produced by the liver, and its purpose is to take and deliver triglyceride to the cells for energy. Once it drops off sufficient triglyceride, it becomes the LDL, or the low-density lipoprotein. The low-density lipoprotein is more so composed of cholesterol. The LDL is the type of lipoprotein which is implicated in causing atherosclerosis, or hardening of the arteries, which contributes to the development of coronary artery disease. The third type of lipoprotein which is produced by the liver is the HDL. The high-density lipoprotein is one which is going to be proportionally higher in protein, so it is higher in density, and its job is to go to transport around the human body through the blood and pick up cholesterol from dying cells to take it back to the liver for reprocessing. So here's another structural view of the lipoprotein. So in the center here we have cholesterol and triglyceride. We have our phospholipids in the membrane coating, as well as protein embedded in the membrane. Essential fatty acids are lipids which must be consumed. Luckily, there are only 2 essential fatty acids for the human body, which must be consumed, and from those the body can create and produce any other lipid that it needs. So essential fatty acids, again, are not produced by the human body, and they're necessary for many bodily functions. They're converted to eicosanoids, which act like hormones in the body. And these essential fatty acids are polyunsaturated lipids. Linoleic acid, or omega-6 fatty acid, is the essential fatty acid which promotes blood clotting, inflammation, muscle contraction, constriction of blood vessels, and it's found primarily in vegetable oils, nuts, salad dressings, and poultry fat. While omega-6 lipids are necessary and essential for the human body, as Americans we tend to eat too many omega-6 in relation to the omega-3s. Omega-3s, or linolenic acid, the other essential fatty acid, is used to produce 2 other fatty acids called DHA and EPA. These fatty acids help to reduce blood clotting, reduce inflammation, cause muscle relaxation, and may reduce the risk of cardiovascular disease, hypertension, and can reduce high triglycerides. So as Americans, we need to try to consume more omega-3 and perhaps less omega-6. Omega-3 lipids can be found in fish, fatty fish specifically, also in vegetable oils such as canola oil and avocados. If we look at the structure, you might be wondering, why are they called omega-3, omega-6? Well, the structural naming of it is based on where the first double bond occurs. So for example, in linoleic acid, the first double bond occurs after the sixth carbon, whereas in alpha-linolenic acid, the double bond occurs after the third carbon. And they are named from the methyl side of the chain. When unsaturated fats are exposed to oxygen, they can become rancid. At this point of unsaturation, oxygen can attack the lipid, causing it to break apart and change the odor and flavor of the oil. You may have noticed this if you had oil stored in your cupboard for too long, and especially if it's a polyunsaturated oil like corn oil, it can become rancid pretty quickly. You may have heard of the concept of hydrogenation in relation to trans fats. We'll look at trans fats in just a moment, but let's look at this process of hydrogenation. This is a process of taking a liquid oil and turning it into a solid fat. An example of this would be shortening. It is made from oil, and hydrogens are added to the point of unsaturation to create a solid substance, which increases shelf life and changes the cooking properties. But it also creates trans fats. These trans fats are changed from the normal cis formation into this trans formation, which mimics saturated fats in the body. Again, during the process of hydrogenation, trans fatty acids are created, going from this cis formation to the trans formation. Trans fats and their content must be listed on the Nutrition Facts food label. As you might remember from earlier in the semester, we took a look at the food labels, and here we have our trans fat content. The one thing to consider, even if trans fat is claimed as 0 grams, you do want to look in the ingredient list for the term partially hydrogenated oil. This will give you a tip-off that there is still trans fat in that product, but it's just occurring at less than 0.5 grams per serving. The reason we want to avoid trans fats is they can greatly increase the risk for heart disease. They increase our low-density lipoprotein and lower the high-density lipoprotein, or HDL. The LDL is the one that can contribute to atherosclerosis, or coronary artery disease, whereas the HDL, we want to keep that as high as possible in the human body because it can actually be protective. But trans fat also increases inflammation and, again, seems to provide similar health risks as saturated fat. Luckily, since labeling has been required, food manufacturers have really been reducing the trans fat content in their processed foods. The FDA has also proposed that trans fats be labeled as an additive, and basically we're going to see trans fats be eliminated from the food source and their food industry in the next several years. So, considering the different types of lipids in our foods, what should we be consuming? Currently, our fat intake recommendations are as follows. 20 to 35% of our total calories should come from fat, but only less than 10% of our calories should come from saturated fat, meaning as Americans, we do need to continue to increase our intake of monounsaturated and perhaps polyunsaturated fats, which come primarily from plant sources. Trans fat, the dietary guidelines basically say just to limit trans fat. However, the American Heart Association recommends less than 1% of calories, which translates to no more than about 2 or 3 grams a day. So it's quite limited in its recommendation. And that takes us to the end of the discussion of lipids. More to come in our discussion board this week.